Hi there, my name is Sumedh Barde. I'm a lead program manager in Microsoft Azure, working on a few things, one of which is Azure Key Vault. Today, we are going to talk about some best practices for how you manage your app secrets. The secrets like certificates, connection strings, and so on that almost every application on Azure has. This is a two-part presentation. The first part is going to be a broad overview of the problems people face, as well as some best practices, and it is a very generic presentation, not restricted to Azure. The same practices apply to just about any place you build your application. It's about a level 100 presentation. The second part is a little deep dive into what specifically you can do on Azure to manage your secrets well. And we'll deep dive into a service called Azure Key Vault that helps you do that in particular. So let's get started. These days, there is a variety of ways in which you can build applications in the cloud. You can deploy VMs, you can deploy containers. There are platform as a service containers on Azure called web apps, logic apps, mobile apps, cloud services, and these days something called service fabric apps, which helps you build distributed applications very easily. Regardless of how you build your cloud app, a common challenge is secrets. Things like certificates, connection strings, your passwords to your VMs and to your databases, even encryption keys. Why is this a challenge? Bad guys are one reason. They are all over the place, looking for your most sensitive secrets. But that's not what we're going to talk about. Why? Because that is actually, interestingly, not the biggest challenge. The biggest reasons why secrets are leaked or you have outages and so on is your own silly mistakes. Oftentimes, developers who are responsible for managing secrets are humans after all and make mistakes, and that's how 80%, and depending on the survey, sometimes it's as high as 90% of data breaches are caused by these silly mistakes. What kinds of silly mistakes? So those little silly mistakes can lead to huge consequences. An example is this. I did a query on GitHub last week for begin encrypted private key, which is typically how PEM files start. Found 17,000 results. I'm pretty sure some developer somewhere thought I'm temporarily going to check this into my source code, and their teammate, without the first guy even knowing, pushed it all the way to GitHub public. Happens all the time. Perhaps you were smarter and decided, instead of keeping it in my source code, maybe I'll keep my certificates on my local file server. But before you know it, maybe your IT guy recycled your data disks and forgot to wipe the data disks. Maybe you decided, I'll just stay away from any central infrastructure. I'll just email all my connection strings to my teammates, all my developer teammates by secure email. So that way, only my developer teammates know, nobody else. But guess what? I bet you somebody is going to forget their phone in a taxi cab. And guess what the taxi cab drivers do these days? The first thing they do is if they find a phone that a passenger has lost, they put them in these Faraday cages so that you cannot reach the phone, and then they sell them in the black market. And there are hackers actually always looking for cheap phones and cheap drives on eBay, because it's not the driver phone, but it's the data on it that they are really looking for. Maybe you decide, I'll keep it just in my head, and that way, no way is this particular secret ever going to go out. It's only during deployment that I actually bring it into my application. But guess what? Now you're risking remembering all your secrets. The time is going to come when it's time to roll your certificate. You're going to forget it, and the next thing you know is this: your website has an outage. So, and these days with continuous integration, continuous build, continuous deploy philosophies in the cloud, keeping it in your head is not an option anymore. I mean, you have to keep it somewhere. So there are breaches, there are outages. Those are not the only consequences. Even compliance violations. Here is a report from last year by Verizon about how companies are failing to keep PCI compliance. For some companies, if you cannot keep your PCI compliance, if you cannot keep your HIPAA compliance, it's game over. I mean, you have to shut down your business until you get back into it. So clearly, big challenge. In the next few minutes, let's walk through some best practices of how to handle secrets anywhere you build your application. These are All right, the first and foremost, you have to know what your secrets are. Inventory your secrets. There is on the web a few ways you can search for patterns in your source code for certificates you may have baked in. Second, source code or SharePoint or file servers are not acceptable places to store these secrets. Please keep them in stores that are explicitly designed for them. There's quite a few products out there. You can bring one of those onto Azure, but we've provided a service called Azure Key Vault in Azure to help you do the same. So in this particular case, let's say this guy in the red is Derek, and Derek works for a company called Contoso. The applications Derek builds, the secrets that Derek brings into that application are not Derek's properties. They are actually Contoso's properties. They belong to Contoso regardless of where Derek goes. And so therefore, Derek is entitled to access these only as long as Derek is in the company's Active Directory. So making sure that all access is tied to your Active Directory ensures that if your people are fired, they lose access. It also ensures one other thing. If all the people who are responsible for your secrets happen to leave the company and just out of mistake forget to hand off ownership to the next people, your company's applications are not orphaned. Your directory admin can always get back in. I talked about people being anchored in directories, but the same thing goes for applications as well. Active Directory and Azure Active Directory in particular has the notion of applications in the Active Directory. They are called service principals. Applications need to authenticate to the Active Directory, and only then they should be able to access your stores. Next, minimize your permissions. There's a lot of people typically on a development team, maybe 50, maybe 100, maybe 500 in large corporations, but really not all of them need direct access to your secrets. There's typically a handful of people who we'll call custodians who need to be able to manage these secrets, add secrets to your key vault or whatever other store that you use, read from them, rotate them, and so on. You might have a large team of developers building a variety of applications. They do not need direct access to your secrets. Their applications do, but again, not all applications do. Only the specific application that needs that specific certificate or key should be granted access. Everything else should not be. If all of those applications have secrets, at least in the case of Azure Key Vault, you can create independent key vaults. A key vault is a free construct. You can create as many of them as you want and grant every application only the rights to talk to its own key vault. At least in the case of Key Vault, and I'm sure many other tools do the same thing, we give you a detailed log of every single access to your Key Vault. We do give you that in the form of a storage blob, a storage account. And that storage account is in the same Azure subscription where you're building your applications and where your Key Vault is. So now you can unleash whatever you want on that particular blob. You can have your security analysts or auditors review that for forensics. You can feed it into your favorite log monitoring tool. There's a variety of things you can do, but keep doing that regularly to make sure that the access pattern for your secrets does match your understanding of how it's supposed to be. Now, you're doing everything right. At Microsoft, we have this philosophy called assume breach, which means no matter how much caution we take, hackers are going to be one step ahead and somehow find their way in. And the best thing you can do is to make sure that you limit the impact of a breach. So make sure you rotate your secrets periodically. Certificates typically should not last for more than a year. If you can rotate every 6 months, 3 months, even better. Same with passwords. Typically you should not have the same password for more than a few weeks. And then finally, humans are humans. So even if you're doing all of this perfectly, humans make mistakes. So once you've figured out the exact pattern of where to get your secrets from, where to put them in, how frequently to rotate, just automate it. Automate the distribution of the secrets to the VMs, automate the logging and the inspection of your logs, and even automate the deployment of your applications. So that way, if your application is deployed every so often, like maybe every night or something, it picks up the latest value of the secrets, and that way you're not working with some old certificate and you don't face an outage. All right, so with that, we conclude the high-level overview of best practices that while we talked in terms of Key Vault, most of that really applied to anywhere you build your application. With that, we'll deep dive into what specifically we do on Azure to make this easy for you. So we have a service called Azure Key Vault. What is it? Azure Key Vault is a secret store as a service. So you don't have to deploy your own software. Once you have an Azure subscription, you can start using Azure Key Vault right away. It's there for you. It's managed by Microsoft. You can use it to store and manage your secrets. And by secrets, I mean things like certificates, connection strings, passwords again. For encryption keys in particular, we give you even better isolation. What I mean by that is for most secrets, you store them, you deploy them to your application, and your application then uses those secrets maybe to talk to a SQL database or maybe to talk to an external Twitter account in order to tweet or something like that. With cryptographic keys, it's a one-way street. You add cryptographic keys into your key vault, you cannot get them out. Anytime you need to use those keys, you call Azure Key Vault with the data and say, hey, please decrypt this for me, or please sign this for me. And so that way your keys are not even if your application gets hacked, all that it can do is keep making calls to the key vault, and for every little thing, it needs to keep calling again and again, and there's a throttle limit on how much you can call. But it cannot steal the key and then go offline. This entire service is backed by hardware security modules. So the secrets that you add, we encrypt them before storing, obviously. That encryption keychain is backed by hardware security modules. They are these tamper-proof pieces of cryptographic circuitry. And if anybody tries to tamper with it, they just zeroize themselves. Azure Key Vault is offered to you as an Azure resource provider. What do I mean by that term? So this diagram on the right shows a hierarchy. At the very top, you have an Azure Active Directory. So if you are working for a company, Contoso.com, Contoso.com has its own Azure Active Directory. All of the subscriptions that Contoso's employees create, all of the Azure subscriptions, are parented to that directory. What I mean by that is to be able to log into that subscription, users need to have a presence in that particular directory. In each subscription, you can have 0 or more resource groups, and this is just a collection of what are resources. What's a resource? VMs that you create are resources. Storage accounts, databases, HT-Insight clusters, they are all resources. A key vault is also a resource just like that. And you can create up to 800 key vaults in a resource group. You can have up to 800 resource groups in a subscription, and you can have any number of subscriptions in a tenant. Inside each key vault, you can have 0 or more secrets, 0 or more cryptographic keys. And for every time you write a secret, we keep the old version in a version history so that you have the entire version history. It's extremely handy in the case of cryptographic keys, where you might always be encrypting with the latest key, but you still need to keep all your old keys because some of the data that you encrypted 2 years ago is encrypted to an old key. So this version concept is extremely useful. All access to your key vault is anchored to the directory. Which directory? Well, your key vault belongs to a subscription. The subscription is parented to a directory. Anybody trying to access key vault, any user or any application, needs to get a token from that directory in order to access your key vaults. On every key vault, you set an access control list, which says which users and which applications can do which specific operations. An example might be Derek can manage secrets, meaning add secrets, delete secrets. Cecil can only read secrets. This particular application can read secrets and use keys for the purpose of decryption. And so you can specify a list of which specific identities can do which specific operations on your secrets as well as on your keys. Those ACLs are expressed in terms of their Azure AD identities, whether it's users or applications. And then finally, Azure Key Vault is integrated with other Azure services. So that way, when you're creating your storage account, programmatically, you can get that storage account key, dump it into an Azure Key Vault. You can use the magic of Azure Resource Manager to distribute it from there into your other applications. And so you're taking the human out of the flow and trying to keep this programmatic. Now, Not all permutations are built into the platform. There are some common ones that we build in, and for others, you can automate it on your own. And how do you automate it? Well, that's because all of Key Vault is accessible via REST API or SDKs or commandlets or cross-platform command line interface. So the Key Vault that you create has a RESTful URI. So in this particular case, let's say you created a Key Vault called Derek's Vault. It's a globally unique name, which is basically that string followed by the suffix vault.azure.net. That whole DNS name is the RESTful URI for that particular Key Vault, and you can HTTP GET, put properties on that particular Key Vault. Every secret that you add to that Key Vault has its own RESTful URI, which is the URI of the Key Vault, followed by the hard-coded word secrets, followed by the name of your secret. In this particular case, let's say you added a secret called MySQL password. That's the URI that you HTTP put or HTTP GET to write your values or to read your values. Earlier, I mentioned that inside we keep every version of the secret that you've written. Well, every time you write your secret, you write to this URI. Under the hood, we mint a GUID and give you back the full URI, the version-specific URI of the secret that just got added. From that point onwards, you can access the latest secret using either this URI or this particular URI. Over time, as you update your secrets, this is the URI through which you get your latest secret value. But if you ever have a need to go back to one of the historical versions, you use the full version-specific URI to get there. Keys are the same way. In this particular case, the key is named MyKey, and the full URI for that is the Vault URI, followed by the hard-coded word keys, followed by the name of the key, and keys have versions as well. So when you want to create, delete, or get properties of a Key Vault, you use the ARM interface. Even setting permissions on the Key Vault happens through the ARM interface. ARM has its own permissions model called Azure RBAC. People who have write RBAC permissions can set permissions for the rest of the operations on the Key Vault. The way you do all of these operations, you can do it through the REST API, you can do it through SDK, command line, and so on. At this point, you cannot create Key Vaults or manage them through the GUI, but you can do them through all of these, as well as through templates. Once you created your Key Vault, you can write secrets, read secrets, write keys, use keys through the Key Vault interface. There again, we have a REST API, an SDK, and at this point, we have a .NET SDK, which is generally available, and we have Java and Node.js SDKs in preview. We have command line interfaces, both PowerShell for Windows as well as cross-platform command line interface if you use Macs or Linux. The Key Vault service is available worldwide as a regional service. At this point, Azure is, I think, I've lost count. It's in so many regions. It's like 22 regions at this point. Azure Key Vault itself is available in almost all of those regions, except the 3 Indian regions that we launched recently. Wherever you're building your application, we encourage you to create your Key Vault in that particular Azure region. So that way, you are only dealing with local network calls. You're not crossing the continent somewhere else. And that's the best way to get very highly available applications. When you create your Key Vault, you choose the region that you want to create it in. So I might create it in West US, East US, North Europe, Southeast Australia, and so on. The keys and secrets that you add to that Key Vault are primarily stored in that particular region. There's 3 copies made in that particular region. We also make 3 copies in a secondary region within the same geography. So if it's in West US, typically the copies get made in East US. This is not something you choose. This happens behind the scenes. In all, there are 6 persistent copies of your secrets, which means you get very, very high durability. Even if an entire data center craters because of an earthquake, your secrets are safe. Anytime you read or write secrets from that particular Key Vault, that RESTful request typically goes to the region where you created your Key Vault. So if you created your Key Vault in West US, then all further requests to it by default go to West US. But occasionally, the West US region might have an outage. Maybe there's a network outage, maybe there's a power outage. In that particular case, Microsoft automatically fails the service over to a remote region. Now, we obviously try to, there's a lot of redundancy within the region, and so we have a lot of failovers within the region itself. If that doesn't work out because the entire region is flattened, then we fail over to the other region. This happens opaquely to you, so you don't have to explicitly take care of this. Net, you get very high availability, even if one or more components inside our server go down. That's a quick bird's eye view of what the Key Vault service is. Next, we're going to jump into a few demos of how to create a Key Vault, how to add a few secrets to it, and how to set permissions. We'll do these demos in two parts. The first parts of the demos will focus on how you manage your key vaults. That shows you how to create a key vault, add secrets, and set permissions. And then the second part of the demo will focus on, now that you've set up your key vault, how do you distribute your secrets from there to the applications that need them? So let's do this particular demo in Azure PowerShell. You can do largely the same things in a cross-platform command line interface, or with Azure templates, or through the ARM REST API also. So first thing, you have to install Azure PowerShell. Once you install Azure PowerShell, open the Azure PowerShell command window, and you have to log into your Azure subscription. In this particular case, I'm Derek at Trey Corp. I log in here, and it shows me, hey, you have one subscription here whose ID is this, and that belongs to the Azure Active Directory tenant whose ID is this. So anybody in my company who sets up an Azure subscription with their Trey Corp USA email address will have a subscription parented by this particular tenant. Now, within this, before this demo, I already happened to create a few Azure key vaults. Get Azure RM key vault tells you all the key vaults I have. It tells me that this particular key vault belongs to a resource group called Direct Dev RG. It belongs to the region West Europe. This other key vault belongs to Japan. And this third key vault is in North Central US. So if I have 3 different applications in 3 different regions, or even the same application deployed in 3 different regions, ideally I would create 3 different key vaults. Now let's create a key vault. Now, if you recall right, my previous slides, I showed you this diagram that showed the hierarchy. And in a subscription, there are resource groups, and resource groups contain key vaults. So the first thing we'll create here is a resource group. If you already have a resource group, you don't need to create it, but we'll just start from scratch here. Okay, so I have created a resource group here whose name is Trey RG. I'm pretending to build this service called Candy Service. And because I'm deploying it in West US, just as a friendly reminder, I named the entire key vault Trey RG, the resource group Trey RG Candy Service, West US. Now, in that particular key vault, in that particular resource group, let's go create a key vault. The command for that is new Azure RM key vault. In general, the pattern for Azure commandlets is as follows. Azure RM is the prefix for anything you're doing with the Azure Resource Manager. In this particular case, since we are creating key vaults, creating resource groups, we are interacting with the Azure Resource Manager, and so we use all this new Azure RM set of commandlets. I created a key vault with this name. I created it in West US. I created it in the resource group that we had just created. And by default, it granted me, I'm pretending to be Derek here, access to do most operations with my secrets. So I can, all operations with my secrets and most operations with my keys. Because it knows that if I created a key vault, I likely will want to next add secrets, maybe check them once in a while, and so on. Now, inside this key vault, let's add a few secrets. The first set of secrets will add are just strings. The first one is a password. Let's say I'm about to create a SQL database, or maybe I frequently create SQL databases, SQL servers in Azure, and I want to set a particular password. And you can see my favorite password here is everybody's favorite password. That's the password I am going to put in my key vault now. And every time I deploy my SQL servers, I'm just going to pick it from there and deploy to my SQL server. That way, I don't have to keep punching in my password every single time. So the first thing I'll do is assign it to a variable here. And that variable needs to be a secure string. So that way, by chance, if I see it here, I don't display it on my screen again. And yes, I did display it this time, but not next time. Now I set that particular key vault secret in the key vault that I added. As you can see, I added it to the vault called Tray Candy Service West US, which I created up here. I set the name of my secret to be admin password, and the value of the secret is this thing that I just set up here. And there you go. In my key vault, now I have a secret called admin password. Going back to the diagram, every secret has at least one version, and as you keep writing secrets again and again, I'll have multiple versions of it. So here, Azure Key Vault just generated a version ID for it, and the full ID of that version specific thing is this. I can use either the abbreviated URI for the latest value of the secret, or I can use the full URI for that particular value of the secret. The same thing can be done when adding a storage key. A storage, as far as secrets are concerned, they are any 25 kilobyte, actually 50 kilobytes, 25,000 characters worth of bytes. We don't really care what it is that you store inside it. It could be a password, it could be a storage key, it might even be a certificate that we massaged as those bytes. We tried to keep this agnostic. So in this particular case, I have a storage key, and clearly I am not going to put this in a notepad, in a text file for a production service, but for a demo, I have put this here so that I don't flub this up. This particular storage key, I massage into a variable and then go back. I use that variable to create a secret, just like we did up there. And now I have the second secret. Now let me enumerate secrets inside this particular key vault. If you recall, once I have created a key vault, all subsequent operations on the key vault talk to the Azure Key Vault service. And that is why these commandlets have set Azure Key Vault and not set Azure RM Key Vault. Same here, get Azure Key Vault and not get Azure RM Key Vault. So here, let me do vault name Tray Candy Service West US. And I said get Azure Key Vault key, and I have no keys. But if I do set get Azure Key Vault secret, I will see two secrets in here. The Tray Candy Service vault has a secret called admin password and a secret called storage key. Now, if I wanted to check the value of a particular secret, I would say -name, that particular admin password. And I will see that this is this particular value. If there were multiple versions, I would have seen multiple blocks of this. Now, let me try to get the value of this particular secret back. So let's say I say my admin secret equals this particular thing. And now I say admin secret. By default, it won't show me the value. That's just to protect you from accidentally showing it while your teammates are looking behind your shoulder. But if I do this, then I can actually see the value. Here I'm consciously saying, no, I really want to see the value. Okay, so now we have added a password. We've added a storage key. What do I need to do to add a certificate? In this particular case, the certificate is a PFX file. I already have a PFX file on my machine whose password is 123. Now, natively recognize all these different kinds of secrets. They are all strings to us. So the first thing I need to do is to load this PFX into a set of bytes, massage them into a convenient base64 string, and then set that string as a secret. And this is what I'm going to do here. The next set, this one loads the certificate from disk into a variable. The next set of commands turns that into a base64 string. And then finally, I want to turn that into a secure string because that's what these commandlets accept. And once I have the secure string, I do exactly what I did earlier, set Azure Key Vault secret. And there you go, I just set the secret. Now if I do get Azure Key Vault secret again, I will see 3 blocks: the password that I set, the cert secret that I just set, and the storage key that I set. Now my Key Vault is ready with 3 different kinds of secrets. I showed this with PowerShell, but I could have done the same thing with Azure templates also. Here's an example. This particular Azure template creates just a Key Vault. If you've never dealt with Azure templates, they are JSON files, and the structure of the file typically is you set a few parameters up here and their values. You declare what resources you want to create. So you want to create a storage account, you want to create a VM, you want to create a Key Vault. In this particular case, we are creating a Key Vault and it's denoted by its type. The name, instead of, I could have written my name here, but I take it as a parameter. And what this allows me to do is I can run this template again and again and again, but just supply different parameters. So if I want to create a Key Vault, let's say in West US and East US and North Europe and West Europe for my application, I likely want to create the exact same set of secrets and the exact same set of VMs and exact same set of storage accounts and so on, but just with different names and different data, but the overall topology remains the same. And that's why these templates really, really come in handy. And that's why I have parameterized this. Location is parameterized as well in this particular case. And now the properties include a set of permissions. We will get into these enabled for flags later on. If I'm dealing with templates, there's one thing that I need to do explicitly, which PowerShell just did it automatically, which is I need to tell the template what tenant I am in. It cannot infer that automatically, unfortunately. These are the access policies. Each access policy is the particular ID of the user or the application that I'm granting access to and which specific permissions I'm granting access to. This particular template does more than just create a Key Vault. It creates a storage account. It creates a Key Vault. It grabs the storage account key from the storage account and adds it as a secret to the Key Vault, all in one template deployment. So I don't, as a human, even see the storage account key. I just kick off this deployment and Azure Resource Manager does all these things under the hood for me. Let's dig into this particular template. As you can see in this particular template, there are 2 resources. This first resource is a storage account. And we won't get into the details of the parameters of the storage account, but that is telling Azure Resource Manager, please go create a storage account for me. The second resource here is a Key Vault, just like earlier. But notice something different over here. There is a third resource now that is secrets. What this block is saying is that, hey, create a storage account, create a Key Vault, and now for this particular secret, please get the storage account key from the Azure storage account that I just created and set its value on this particular secret in this particular Key Vault. And the name of the secret is something that I supply as a parameter. So now that you have a Key Vault with some secrets in it, a password, a certificate, and a storage account key, let's see how you distribute them from there to the applications you're writing in the cloud. And again, remember the goal was to distribute this programmatically. We don't want humans in the flow. You could certainly read the secrets back from it and then deploy it, but no, that's not what we want. We want to do this all without human beings. There are a few ways to do this. The first is via the Azure Resource Manager. This method is perfect if you're distributing secrets as parameters to the resources you're creating. As an example, through the Azure Resource Manager, you create VMs, you create SQL servers, you create web apps, and so on. The VMs and SQL servers have admin passwords, and those are typically secrets. So you don't want a human being to punch it in as part of the deployment. You don't want the password to be lying somewhere in your source code. So you want to take that password from your key vault. The Azure Resource Manager helps here. So you can ask the Azure Resource Manager as part of your template to read a particular secret, password in this particular case, from your key vault, and pass it in as a secure string to the VM or VMs or to the SQL servers that you are creating. The Azure Resource Manager actually passes it to the compute service or to the SQL DB service, which in turn then distributes it to the VMs that it is about to launch or to the SQL servers that it is about to launch. Now, to be able to do all this, you have to set permissions in your key vault. Specifically, you need to grant the Azure Resource Manager permission to read secrets from your key vault. And you do that using something called Enabled for Deployment. We'll get into the exact specifics of the template here, but let me just do a breadth-first overview of the other methods that you can do this in. How about certificates? Well, you can authorize the Azure Compute Service to read a certificate from your key vault and launch and inject it into your VM just as the VM comes up. And you do the same flow if you need to update the certificate later. So this saves you from embedding the certificate into your VM image, which is a big risk because if your VM image ever gets stolen, then you lose the certificate with it. So with this, you can keep a vanilla VM image without the certificate and keep the certificate in the key vault and then deploy it. The other benefit you also get through this mechanism besides security is management. So imagine you have 500 VMs. You don't have to manage those 500 certificates separately. On a Windows PC, you have this thing called a certificate store. That's one central place that you keep your certificates, and all your processes take it from there. Think about Key Vault as the certificate store for your Azure subscription. You keep all your certificates there, and you can manage them in one place, renew them in one place, and then just tell the compute service, hey, I have a new certificate. Can you please patch up my VM, please? And it will just redeploy to your new VM. Similar facility exists in the Azure Web Apps service also. Azure Web Apps service will take your SSL certificate and actually front-end SSL for your web apps. And for other kinds of certificates, it will take it from your key vault and distribute them into your web apps. And oh, by the way, the previous flow, you can tell the Azure Compute Service where exactly you want to place this on the target VM. If it's a Windows VM, you can tell it specifically which certificate store. If it's a Linux VM, you can tell it the location on the in the directory where you want to, the directory and file name where you want to place the certificate. Now, the third mechanism is where your application directly reads or writes secrets from your key vault. To do this, your application needs to authenticate to Azure Active Directory. How does it do that? It needs some kind of credential. Well, you piggyback on top of the previous step. You use this step to inject a certificate into your application. Now your application has a certificate. Assuming you have registered your application with Azure AD and you registered that certificate thumbprint with Azure AD, that application can now log in to Azure Active Directory, get a token, and use that token to read or write secrets from your particular key vault. And this thing is a dynamic operation. So we have applications that read or write secrets actually every 20 minutes. The other thing is, it's highly likely that if you are a large development team, you have your own deployment engine. You're not really starting from scratch by deploying individual VMs or individual web apps or individual containers. In that case, one thing you could do is to modify your deployment engine to do exactly what Azure Resource Manager did earlier, which is you could authorize your deployment engine to read secrets from your key vault, for which your deployment engine needs an Active Directory service principal. So you need to register that in Active Directory. But once you do that, you can grant it permissions to read from your key vault, and then your deployment engine can read from it and then push those secrets into your applications, whether they're containers or VMs or web apps or however you build them. So that's a good breadth first overview of the different mechanisms. Now let's go back to the first slide and look at how exactly to achieve this in templates. So remember here, we are authorizing the Azure Resource Manager here to read from secrets. Let's see how to do that. So the Azure Resource Manager is a known entity in Azure. Doesn't need an explicit Azure AD identity that you need to think about. So we have baked in a flag on Azure Key Vault called enabled for template deployment. That tells us, the Azure Key Vault service, that when the Azure Resource Manager comes in, we should let it read your secrets. So let's actually set this particular permission on the particular Key Vault that you had created. Now if I say get Azure RM Key Vault, and I say tray candy service, I will see that apart from me, the Azure Resource Manager is also allowed to read secrets, and this is denoted by the flag true for this particular, the value true for this particular flag. Now that I have set permissions, the next thing is to tell Azure Resource Manager to actually read these secrets and deploy them as passwords. So here's an example of how that does it. Now, the example here does this for a SQL server. It's the same thing for a VM. In this particular case, I am creating a SQL server. So I'm creating a resource and whose type is Microsoft.SQL SQL servers. It has two properties. One is administrator login, which is a parameter that I pass in, and this is fine to be a clear text parameter. But the next one is administrator login password. And this one is a parameter that should not be passed in clear text. Let's see what we do here. Now, in this particular template is a two-part template. This parameter is defined right here. This is the login itself, and I can put whatever value I want, like admin. But this is the password. And instead of punching in a value right there, like I've done up here, notice what I've done here. Here I'm referring to a particular secret in a key vault. I need to punch in the ARM resource ID of it. It's this thing that I need to punch in there. And the particular secret name in it is admin password. I had added this earlier in one of the earlier steps. So now when this template is deployed, the Azure Resource Manager reads this particular secret from your key vault, passes it back to the Azure SQL service, and the Azure SQL service then now takes it and sets that as the password for the SQL server it's about to create. So that's an example of this particular flow. Now let's go look at the next flow, which is distributing certificates. In this case, again, all permissions on Key Vault are explicit. We don't grant anything by default. So I want to enable the compute service to be able to read secrets from my Key Vault. Well, how do I do that? There's a permission for that called enabled for deployment, to be distinguished from enabled for template deployment. This is VMs and this is ARM. So I will set this particular flag. And now you can see that the permissions just grew on this one. And now I've not only enabled the Azure Resource Manager, but also the compute service to be able to read secrets. And how exactly do I tell the compute service next to read that? Here's a template to do that. This particular template creates a VM. As you can see, here's a resource block, and the type of the resource I'm creating is a virtual machine. There is one specific property of the virtual machine which has a structure. It's a well-known property that has a structure underneath it. There's a computer name, there's an admin username, and an admin password. For the admin password, I would use the previous technique that I just showed to feed the password from my key vault into in here. But let's focus on the next section, which is certificates. This particular syntax, secrets, followed by the ID of the key vault, followed by the URL of the particular secret in the key vault that has my PFX, is what I need to specify here. And the next one tells where do I want to deposit this on the final VM. So when I run this, the Azure Resource Manager tells the compute service, hey, by the way, here is the place where you will find the certificate. The Azure Compute Service parses this block, makes a call to the Key Vault service to read this URI, and then deploys it into the particular VM at this location. So when the VM comes up, you'll find this. In this case, it's a Windows VM, and this certificate gets deposited in a certificate store. This might as well have been a Linux VM, and there is syntax here to say where exactly to deposit it on the Linux VM, on the hard drive. There is a similar syntax for Azure Web Apps. Let's go to the third flow. Your application is now bootstrapped. It has a bootstrap credential. It needs to log in to Azure Active Directory and then read secrets, or maybe even write secrets to your Key Vault. To do that, the best place to go is the Azure SDK GitHub repo, where we have some Key Vault samples. There are two samples inside this. The first sample is called Hello Key Vault, and this shows every REST call on a Key Vault. In its app.config, you need to punch in the URI to your Key Vault. You need to punch in the app ID. So this requires that you register your application in Azure AD first. Always, all applications that need to access Key Vault need to be registered. And this is the app ID that Azure AD gives you. And here is something called client secret. Now, this particular sample, we wanted to keep this simple, so we punch in a secret. But the other sample that we have over here in this repo, called Azure Web Service, is really the way a production web service needs to be written. It logs into Azure AD not with a secret, but with a certificate. Certificates can be deployed, as mentioned earlier. It's a much secure way. For the sake of brevity, we won't get into the Azure AD portions of this, but let's just directly jump into how to do the Key Vault portions of this. So over here, you see, assuming this application is already logged into Azure AD with its client ID and its certificate, to read a secret in .NET is as simple as this. You instantiate the Key Vault client class, and there's one method that says get secret async. You pass in the URI of the vault, you pass in the name of the secret, and if you want, optionally, the version of the secret. If not, you'll get the latest version, and that's it. You get the secret value back. And you can do this at runtime all the time. There are similar method calls to write secrets as well, to use keys, and so on. And this particular Hello Key Vault sample shows you all of those together. Where are these samples again? These samples are on GitHub. Or you can just search for Azure Key Vault samples, and there is a downloadable package on the Microsoft Download Center also. But if you go to Azure SDK for Net, under that you see source, you see Key Vault, and actually the entire Azure PowerShell source code is in here also. These are the samples. And the README over here actually does a pretty good job of describing what you need to do to configure the sample and run the sample. So with that, we will leave the rest to these URIs up here on the screen. We have a lot of documentation on how to manage Key Vaults through PowerShell, through CLI, and we have sample code to go with it. So with that, happy Key Vaulting.